Hey everyone, welcome back to another video from Smart Interviews. So today we're going to discuss the problems under the CodeChef Contest Starters 135 under Division 3, and the problems that we're going to discuss are football ties, invert and equalize, change A to B, graph cost. These problems are like very good standard problems, and if you see here the accuracy is less than 20%. I am Sanjay Kumar. Let us begin with the contest. Starting with the first problem, football ties. So the problem statement goes something like this. According to the Premium League rules, the winner of a game gets 3 points while the loser of a game gets 0 points. On the other hand, if there is a draw, both the sides get 1 point. Two teams A and B played several games each other and finally end up with a score X and Y respectively. So we do not know how many games they were played. Finally, we are supposed to find the minimum number of draws that will actually happen. So it was also mentioned that it is guaranteed that there is exact one way in which we can get the score X and Y points respectively. Looking at the constraints, T's number of test cases are less than or equals to 75 and X and Y are less than or equals to 14. Okay, let us see how it is. So if we talk about the first test case, that is 1 and 1, so clearly it indicates that they have played only one game and this one game is a draw. So because of this, team A got 1 point as well as team B got 1 point. Okay, taking up the second test case, this is first one. Let us go to the second one. So this is 3-0. So as this is 3-0, what can I say about this? 3-0. So can I just simply say they only played one game? They only played one game and team A won and team B lost. So because of which they got 3,0 as a score. Yes. And taking the third example, 11-5. So we can simply assume that 11-5. Yeah, they might have played six games. So here it won one match, right? Yeah, in the same manner, they might have played 6 games. And out of these 6 games, Team A might have won 3 games. So if it won 3 games, the score is going to be 9. And Team B might have won one game, and if it is 1, the score is going to be 3. And left over, so we are done with 3 matches here and 1 match here. That means 4 matches. We are done with 4 matches and left over with 2 matches. So if there are 2 matches, that obviously might have been draw. So if they are draw, so +2 for here and +2 for here. So total what the number of is going to be 11 as well as 5. Same number we got, 11 and 5. And talking about the last test case, so it is 9-9. So we can simply assume that they might have played 6 games once again. 6 games. In 6 games, Team A might have won 3 games, so it is going to be 9, and Team B might have won all other the remaining 3 games. So 3 is going to be 9. So total it is going to be 9, 9. Yes. So for this, if we see number of draws, there are 0 draws. So for this we got 0 draws. If you see number of draws here, these are the draws, right? 2 draws. Yeah, we got 2 here. And if you see here, there are no draws here as well as here. As this is a draw, we got only one. Yeah. So these are the values that we are going to get. So this is actual given problem, and for this problem, we have seen for each and every test case. Yeah. So finally, we are supposed to print number of draws. Yes. So how can we get this? Yes. So obviously, if a team won, it is going to get 3 points. Obviously, if it won, it is going to get 3 points. But what about the opponent? What about the opponent? Opponent is going to get 0 points. Yes. So if it is going to get 0 points, if this team won, as is going to get 0 points, so we can simply get the number of times the team A won and as well as the number of times team B has won. Yes, simply we can get, right? Because so if it won only, it is going to get 3 points and other is going to get 0 points. Yes. So based on this, if you want to get simply how many number of times that does team A1, how can we get, let us say for 11, how can we get number of this? Can we just simply apply by 3 here? Yes. So if you can simply do something like this, what do we get? So we get 3 games. So that means team A won 3 games. Yes, it won 3 games. So after winning 3 games, the score is going to be 9, but actual score, the final score, that is 11. So it is actually making sense that there might be 2 draws which might lead the score to 11. Yes. Let us also apply the same process for the opponent. Yes, opponent, and he got 5 in total. He got 5 in total. So if you can simply somehow find to get number of times this team B has won, can we just simply apply by 3 here? Yes. So we are going to get 1, but the resultant is going to be is something like 3 plus 2. Can we just simply add 2 here? That is going to be 3 plus the value 2 here, assuming as 2 number of draws, so which actually leads the score to 5. So can we just simply say that these two number and these two number are draws here? Yes. So that is what we are supposed to print. So can I just simply apply by 3 to get number of times this team has won? In another term, another side, if you want directly this value, can I just simply apply it mod 3 for this to get 2? Yes, obviously we can simply apply mod 3 for this to get the value 2. Yes. So let us go back to the question. Yeah, let us go to code. Yeah, so this is all about the scanner. I'm just taking a scanner is equals to scanner new scanner of system routine, and for each and every test case I'm not supposed to perform this operation. So this is all about reading the test cases. After reading each and every test case, we are supposed to loop on each and every test case to get the values A and B. Yes. So reading the values A comma B. So after reading these values, we got the logic. So what is the logic? Just simply apply mod 3 for this. We can apply mod 3 either on A or else on B. Anything will be giving the same. Yes. So can I just simply print this saying that system dot out dot println of what I need to print? A mod 3. So this is going to the final code. Let us run it now. Yeah, let us exit the full screen. So 1020 is the expected output. We got 1020. Let us submit this. Yeah, this is saying the correct answer. Moving to the next problem, invert and equalize. You are given a binary string s of length n. You can perform the following operation on it. Choose a continuous substring such that all of its characters are equal and then invert the whole string. And for example, if it is this binary string, we can choose all these ones here in between and we can simply turn these all ones to zeros. And you're supposed to find the minimum number of such operations needed to convert this entire character which contains either entire zeros or entire ones to make all characters of s equal. Yeah. So this is the given problem statement. So if this is the given string, the output for this example is going to be 2 because at one operation you're going to convert this entire ones into zeros. Yes, and which actually turns the entire string into this. And in the second operation, you're going to convert this 1 into 0, and it is going to be the second operation. The entire string will be 0 for the second operation. Yes. So if you see here, so 1 0 for this, the output is 2. Yes, moving to the next example, that is 0 1 1 0. So if it is 0 1 1 0, there we have two operations, something like, sorry, two possibilities. Either we could simply convert this two ones to 0, or else we can simply convert this 0 into 1 as well as this 0 into 1. Yes, so if you want to convert this 0 into 1, it is going to take one operation, and once again if you want to convert this right leftmost 0 into 1, it is going to take once again one operation. So overall it is going to take two operations, but out of these two, you can also perform one operation by just simply converting these two ones into zeros. So out of 2 and 1, the minimum is going to be 1. So you're supposed to return the minimum number of operations in which I can convert the entire string with all the same characters. So output is going to be 1 for this example. Yeah. And for the next example, that is 1 1, sorry, that is 1, which is already like satisfies the conditions that are mentioned above. Something like all the characters in this entire string are equal. So this is going to take 0. Okay, let us deal about this example. Okay, so that means the given example is something like 1 0 1 1 1 1 0 0. So for this, obviously, what is going to be the output? Output is going to be 2. So output is going to be 2. So how did we figure out like output is going to be 2? Yes, so because if you can see here, we have this entire substring with all ones, this substring with 1. Yes, so if we can simply convert this entire substring into ones, so it actually becomes 1 0 0 0 0 0 0 0. In one operation it turns to this, and in second operation if you can simply convert this one into a 0, so it actually looks something like this. So 0 0 0 0 0 0 0. So overall it is going to take two operations. Yes, on the other hand, what else I can do? Can I just also do something like this? So as this is 1 0 1 1 1 1 0 0, can I just simply count the number of zeros, number of substrings of zeros? So here we have a substring of length 2 with two zeros. This is a substring of only 1 0. So can't we just simply perform the same operation here, something like this? At this point, I'm going to take this substring, convert this substring entirely to ones. So it is going to be 1 0 1 1 1 1 1 1. So at the second operation, I'm going to convert these zeros into 1. So it will be something like 1 1 1 1 1 1 1 1. So either to convert into zeros or to convert into ones. So it is going to take the entirely two operations. Yes, making sense, right? Two operations. So you're supposed to return the minimum number of operations in performing these two ways. So minimum is going to be 2 for this example. So if we take a different example, let us say if it is 1 0 1 1 0 0 1 1. So if you can somehow convert this entire string into all ones, 1 1 1 1, or else it may just simulate all zeros as well as all ones, how many number of operations does it actually takes to convert this entire string into all zeros? Yes, so if you want to convert this entire string into all zeros, you're supposed to modify these, right? Let me take a different color for this. Let us take this as this. Yeah, this to be a green. Yeah. So if you want to convert this entire string into all zeros, so that means we are supposed to convert this substring into 0 as well as this substring into zeros, three zeros, and this substring into three zeros. So entirely we got three parts of such kind, three sets. Yes. So can I just simply say, if you want to convert this entire zeros, it is going to take three steps. That means three operations. On the other hand, So if you want to convert this entire substring into all ones, which all things we are supposed to modify? Only zeros, right? So this is one substring with 0, this is another substring with two zeros. So if you see here, we can simply modify these two substrings. That means in two operations we can convert this entire substring into all ones. So for this the output is going to be 2, and out of this what you're going to return? Obviously the minimum. So the objective is very simple. If you can somehow get the minimum, like the minimum, like the number of parts, let us say this is one part and this is second part, and for this above example this is first, second and third. So if you can somehow get the number of parts, is it very simple to get answer for this example? Yes. So how can we get the number of part, number of substrings of all ones, number of substrings of all zeros? How can we get this? Okay, let us see. If it is 1 0 1 1 0 0 1 1, so if you are aiming to count all zeros, let us say we are firstly aiming to count all zeros, or yeah, let us say we are aiming to count all zeros. So if you want to count all zeros, what else can I say? So when I just encountered a zero, I need to count this. Yes. So when I just encountered a zero, I need to just increment my count. Let us first take my count, that to be zero in the very start. Yes. Start with this. Is this a zero? No, this is not a zero. Is this a zero? Yes, this is a zero. So when this is a zero, what I'm supposed to do? I need to somehow increment my count. Now count my count becomes 1, and moving back to this, moving back to this. Is this a zero? No, this is not a zero. Is this a zero? This is not a zero. And when you encounter here, once again you're going to get this zero. Yes. So when you get this zero, can I just simply increment my count here, saying that 2? But if you perform this kind of operation, for the next zero you're going to make your count to 3, which is not a valid thing because you're having only two sets of such kind. Yes. So somehow we need to get only 2 as output for this example. So how can we get this? How can we get this? So instead of just simply, this process actually counts the number of zeros. So instead of simply performing this kind of operation, what if you can simply also maintain an extra flag variable? Let us say initially the flag is false. Yes, initially let us assume the flag is false. Let us start from here. Starting from here. Yeah. So when you encounter a 1, the flag, if it is true, you're going to convert into false. Okay, let us assume, like, if it is true, you're going to convert into false. Yeah. So when you encounter this 0, what is the primary thing that we are supposed to do? We need to simply increment my count. So my count will become from 0, it becomes to 1. Yeah, it become 1. So after my count has incremented, that means I have encountered a 0. If one other 0 is present just adjacent to it, do we need to count it? No, we do not. So can we just simply maintain the flag that we already had to false now? Yes. So I'm going to turn this flag to true. Yes. So what is the condition that I maintain, so that I'm going to count this? If, let us say, this is a ch, that is a character. If that is equals to 0, what I'm supposed to do? I also need to check whether the flag is true or false. Yes. So can I just simply check if not flag, that means if not false, that is if that is going to be true. So if this is the condition, what I'm supposed to do? Just increment my count plus equals to 1. Count will be incremented, and as the count has incremented, what is the next step? I'm supposed to even mark my flag to true. So can I just also perform this operation? Flag equals to false. So this is the thing that you're going to perform when your ch, that if that is equals to 0. But what if it is not equals to 0? What if it is not equals to 0? At this particular point, you're going to get this 0, that is a ch, and you have incremented your count, that is 1 currently. Yes. And flag is true currently. Moving back your ch, when you try to move this ch moves to this particular point. Yes, this is a ch. So when this is ch, you're going to say, if this is 0, no, this is not 0, you're going to enter into some other condition, and you move on and moves to this particular point. So when you move to this particular point, you're going to say that yes, this is a 0, and you're going to compare the flag. Is the flag equals to 0? Like, is the flag equals to false? No, it is not equals to false. You're not going to increment, but obviously you're supposed to increment the account, but this is not possible. So how can we handle this? So at any point when we have encountered a 1, can we just simply make my flag to once again to false? Yes. So in the else, can I just simply say flag equals to true? Yes. Yeah. So initially it is false. So as this is false, we are supposed to make it true. So after making it true, we are supposed to make it false here. So with this we are going to get the number of sets of ones as well as number of sets of zeros if we can simply perform the same operation for all zeros. So finally, what is going to be the answer? The minimum number of sets we have for all zeros as well as all ones. Yes, this is going to be answer. Okay, let us move back to the problem. Let us exit the full screen. Yeah. So for this, so this is all about reading the input something like test cases. Move to the next line. For each and every test case you're going to read the value n, as well as moving to the next line we are going to read the string that we are required, and finally we're supposed to return some output that we are going to handle now. Yes. So we are supposed to get the count of number of sets of ones as well as count of number of sets of zeros. Yes. So let us write some function for this. Public static some int function, int is a function, int, let us say the name of the function is count substring ones, that will be fine. Substring ones, and what is the thing that you're going to pass for this? The string, right? Yes, string s, let us see. Yes, so for this string, what is the first thing that you're going to do? What all things do we actually require? We are required the count that you're going to return finally. Let us take it int count equals to 0. We have initialized count to be 0. After taking this, what is the next step? We also require something like flag. Yes, boolean flag equals to, as I said initially, false. We have taken this. So after the next step, after this, what is the next step? We're supposed to iterate on the string s, and for each and every time we are supposed to check if it is a 1 or else 0. Yes. As this is count of ones, let us implement in this manner. Yes. So for let us say ch of s dot to char array. So we're going to convert this into character array. So for ch s dot to char array, if if that is equals to a 1, what we're supposed to do? We're also supposed to check whether the flag is false. If flag, if not flag, can I just simply increment my count plus equals to 1, as well as what is the next step? I also need to mark my flag from false to true. Flag equals to true. Yes. So we are done with this. So if it is a 1 and if it is not true, we're going to increment our count and make flag as true. So after this, what if it is equals to 0? Yes. Else what I'm supposed to do? Else I'm simply supposed to make my flag to false. Flag equals to false. And finally, what I'm supposed to do? I'm supposed to return the count that actually I got. Yes. So this is all thing for getting the number of sets of ones. In the same manner, if I want the sets of zeros, how can I handle this? I'm just copying the same code and pasting it here, saying that sets of zeros. And what I need to count? I need to count all zeros. Yes. And finally, I'm going to return this count. Here in my output, what I'm supposed to do? Yes, I am supposed to take this and as well as print minimum of this. So can I just simply start system dot out dot println of what I'm supposed to do? Minimum, something like math dot minimum, minimum of what and what? Yes, count number of zeros as well as count strings of ones. So let me take it. Minimum of this. What I'm supposed to pass? S as well as this is not ones, this is going to be zeros and pass S for this. So this is what we are supposed to print. Okay, I might have forgot to add okay semicolon here. So I got like instead of string, I just wrote string. So we got output as 210. Let us verify it once. 210. Yes, let us run. Let us submit it. Yeah, we got all the test cases passed. I hope the solution is clear. Moving to the next problem, change a to b. So you're given positive integers a, b as well as k. You for a variable x with an initial value a, you need to achieve the target value b. In one operation, you can perform either change x to x plus 1 or else move x to x into k. You're supposed to find the minimum number of operations needed to convert the value a into b. So that means you are given two values a and b along with the other value that is k. You're supposed to somehow convert this value a into b with the help of this value k. In one operation, you can perform something like a is going to be a plus 1 or else a is going to be a into k. At some particular point, this will reach as b and we're supposed to find the minimum number of operations to convert this operation. Yes. So let us take an example 182. So if it is 1 8, a is going to be 1 and b is going to be 8 and k is going to be 2. So with the help of k, I need to convert 1 into 8. So how can I convert this? So what if I can simply multiply 2 to this one? So it becomes 2. In the next time, what if I can simply multiply 2 once again to this? It becomes 4. Once again multiply 2 once to this, it becomes 8. So that means I have just performed 3 operations. So in 3 operations, I just got this value 8. Yes. Let us take these examples as well as let us run it. Yeah, 182 and 382, right? Yeah. So as it was said, 182. So 182. So what all possibilities that actually exist? Okay, let us start from 382 for the better sense. 382. Yeah. So if it is 382, for this value 3, if I want to convert into 8, what all possibilities do we have? Yes, for this 3, if I want to convert into 8, what are the possibilities? I have the possibility that I can simply add 1 to this, so it becomes 4. Yes, and what are the possibilities? I can simply multiply 2 to this, and it becomes 6. Let me write it here. Multiply with k plus 1. Yeah. And what about this 4? Is this equal to 8? No, this is not equal. So what else we are supposed to do? We're even supposed to perform the exact same kind of operation. So now it becomes 4 and the value of b and k remains as it is, that is 8 and 2. Yes. And for this value, let me also write this 8 as well as 2 and 6, 8 as well as 2. And for this value, if you want to even extend, what else can we do? So this 4 will becomes 5 in the next step. Yes, because if you're incrementing by 1, yes, in the next step, in one more step it becomes 6, in one more step it becomes 7, in one more step it becomes 8. So let me reduce the size. Yeah, so in one step it becomes 5, in one step it becomes 6, in one step it becomes 7, in another step it becomes 8. So finally you're going to get this 8 in these many number of steps. So all these are plus 1 plus 1 plus 1 plus 1. And what all possibilities do we have? Yes. So at this particular 4, can we just simply multiply 2 to this? Yes. So if we can simply multiply 2 to this, it looks something like this. So multiply with k, and that is 2, and it becomes 8 here. 8. Yeah. So at this point itself, we got an answer that is 8. That means our value a has started from 3 and ended at 8 here. Yes. So this is one way of getting. Let us also explore all the ways of getting. Yeah. At this particular point of 5, we're done with all the ways of 4, right? Because when we encounter 8, do we need to even explore further? Not at all required. Yes. So let us go with 5. So if it is 5, what all possibilities do we have? Once again, I have just incremented 1, and what all possibilities? I may be doubling it. Yes. So if I want to, sorry, if I need to multiply with k, that means here it is doubling. So if I want to multiply with k, it becomes 10. Yes. So at the point it becomes 10, do we need to even extend it further? Yes. So this value that is 10, which is even larger than this 8. So as this is larger, do we need to extend this? Not at all required. Not at all required. So at this time, instead of extending it further, you can simply stop it here. And what about the 6? If you can simply apply the same process for all the values, it will be exceeded. Yes, it will be exceeded. So we are not supposed to consider this. Yeah. And let us go to the right side part. Right side part. So it is 6, 8 and 2. So if it is 6, 8 and 2, what are possibilities? So for 6, I maybe need to multiply 2 to this, or else I can simply add 1 to this. Yes. So if I can simply add 1 to this, it becomes 7. And once again, if I can simply extend, if it becomes 8. Yeah. And what all possibilities on the other side? I can simply multiply 2 to this. If I can simply multiply, we get 12 here. But is this 12 less than or equals to 8? No, it is not less than or equals to 8. Do we need to even extend further? Not at all required. So for all this, not at all required to extend it further. So at this point, we got 8 as our value b. Sorry, our value a has turned into 8. So these are two possibilities in which I can get this 8, as well as this is another possibility in which I can get this 8. And out of all these possibilities, what I'm supposed to return? The minimum number of operations, because each and every step here takes one operation. Making sense, right? So this is one operation, this is second operation. In two operations, you can reach, like, you can get 8 from 3 in two operations in this path. So if you follow this path, you're going to convert 3 into 8 in just two ways. Two operations, in just two operations. Yes. And if you try to extend this something like in this way, how many number of ways, like how many number of operations it actually takes? Yes, it is going to take seven number of operations. Seven number of operations. And one other we have, that is seven number of operations. On the other hand, we have few number of, like, 1, 2 and 3. So on the other hand, we also have three operations in which we can reach the value 8. Of all these, what we're going to return? The minimum. Yes, we're going to return the minimum. And what is the minimum? 2 is minimum here, which you're going to return as our answer. I hope that is clear. Yes. So let us convert this logic into some kind of pseudocode. So as I said, at each and every step we have two possibilities. Either we can simply add 1 to this or else add k to this. So multiply k to this. So let us simply assume int min operations. Let us first assume we are going to write a say, recursive code because we are going to perform the similar kind of operation multiple times. So minimum number of operations. What all things you are required to pass to this? Yes, A is there, B is there, as well as K. Yeah. So for this, what is the first step? Yes, I need to return what? I need to return what? Out of all these possibilities, what I need to return? I need to return the minimum. Yes, I need to return the minimum. Let us first assume this function is going to give us the minimum number of operations to convert A into B with the help of K. Yeah. So after this assumption, we are going to the main logic. That's something you're going to return. So you're going to return minimum of min operations, and at some particular point, what actually happens to A? A has incremented by 1. Yes, A plus 1. And what about the value B? It remains as it is. And what about the value K? It remains as it is. Minimum of this. And what is the other possibility? I'm going to multiply K to A. So can I just simply call the min operations of A is multiplied with K, B remains as it is, as well as K remains as it is. Yes. So I'm going to return the minimum operations. So if you see here, if I want to convert this 3 into 8, if I can somehow know the number of operations in which I can convert 4 into 8, what else we are required? What else we are required? We can simply add 1 to this, and say the number of operations that is going to take by 4 plus 1 operation is going to be one way of doing, as well as the number of ways of calculating, like getting the value 8 plus one way of doing is going to be one other. So can I just simply add 1 to this, saying that minimum of this and this plus 1, instead 1 plus minimum of this and this. That is what I'm going to return. So this actually goes to the main logic, and next comes base conditions. So let us try to figure out the base conditions. Let us say instead of 3, 8, 2, what if it is given something like 3, 3 and 2? Yes, the value of A is 3 as well as the value of B is 3. So when A and B are equal, do we need to perform any kind of operations? Not at all required. So when A and B are equal, A and B are equal, do we need to perform any operation? Yes, not at all required. So if A is equals to B, can we just simply return 0 from here itself? Return a 0. Yes, you're going to return 0. So that is fine. And what about this other case? So we have handled this. So value of B is 8, and at some particular point we got value of A as 8. We have handled it. And but what about this particular value 10? What about this particular value 12? And what about all these values which exceeds the value of 8? Yes. So at this particular point, do we need to consider these values? Not at all required, right? We are not at all required to consider these values. So that means if we want to not consider these values, what value we are going to pass, what value we are supposed to pass from this? Yes. So if you see here, I want to get minimum of both the sides. So if I want to get minimum of both the sides, if I want to omit some particular part, obviously that part should be the maximum. Yes, if it is maximum, I'm going to omit this. So what else can I can do? I can simply return some maximum value here. Yes. So if I can simply return some maximum value, this part will be omitted and only this part will be considered. So I'm going to say another condition saying that if A is greater than B, what I'm going to do? I'm going to return maximum value, that is int max. So this is the entire logic. So let us try to convert this logic into code, let us convert this pseudocode into the main code. Let us execute this. Yeah. So this is all about reading the test cases and all about the input. Let us print the output here. So for this, as I said, we are going to write a function for this. Yeah. So public static is going to be an integer function. Let us say minimum operations, and what are the things that you're going to pass to this? A, B, and K. Let us say int A, int B, int K. Yes. So along with this, yeah, we are required to pass A, B as well as K. So what is the first step that we are supposed to do? Yes, we're supposed to return something. What you're going to return? Return min. That means math dot min of, yes, call the minimum operations, the same function with the value of a plus 1 in the very start, b remains as it is, a remains as it is, as well as min operations, a multiply with a, b remains as it is, as well as k remains as it is. We are done with this. Let us go to base conditions. Yes, as we discussed, yeah, so we left something like 1 plus minimum number of operations, right? Yeah, 1 plus. Coming to base conditions, if a, if that is equal to b, what we're supposed to do? Return a 0. So we're going to return 0. Let us also take a semicolon here. And what is the other possibility? If a exceeds b, at this point, what you're going to return? Return some maximum value. Let us say integer dot max value. This is what you're going to return. So if it is equal, you're going to return 0. If it is greater, you're going to return maximum value, or else you're going to return 1 plus math.min of this as well as this. Yes. So let us call this function from here. Something like system dot out dot println minimum operations on A, B as well as C. So this is the entire logic. Yeah, semicolon return. Therefore, semicolon expected, not a statement. So where did we miss a semicolon? So this is return. So we got something like stack overflow. So if we see about the test cases here, the maximum value of a comma b can go up to 10 power 9, up to 10 power 9, and the value of k can go up to 10 power 9. And if you see the first test case itself, in the first test case itself, we got a value that is 10 power 9, which is really a large value. Okay, so for this, let us do one thing. Let us try to remove this. Let us say only 3 test cases we will have. I'm going to remove this. Yeah, let us try to run it now. So we got our answers as 322. Let us exit the full screen and let us see here. So the output is 322 for the first 3 test cases, and for the last one we got Stack Overflow. And if you try to execute in some other language, maybe you're going to get time limit exceed. So obviously the logic for this is having a lot of complexity. Obviously we are supposed to optimize this. Yes, let us see. So what we're actually performing here, so at each and every level we are trying to increment this value a, yes, increment this value a to make this value equals to b at some particular point. Instead what if you can simply apply the reverse process, something like instead of converting 3 into 8, yes, instead of converting 3 into 8, what if you can simply try to convert 8 into 3? Yes, let us see something like back, moving in the back way. Yes, so let us take this example: 3, 8, 8 as well as 2. So if it is 3, 8 as well as 2, in 8, how many number of operations does, like how many number of times we might have multiplied 2 to this 3? Yes, how many times we might have multiplied 2 to this 3? Yes, let us see how many times we have multiplied. So in the very start, you're going to say 3 plus 1, that is going to be 4, and 4 you're going to multiply with 2, you're going to get 8 here. So this is the way you're going to perform this operation, and which you're going to get 8. So instead of this, if you can simply convert this into something like 3, 4 and 2, 3, 4 and 2, at this particular point, we can simply say 4 is just 1 greater than 3. That means we got this as 3, 3 and 2 by just incrementing 1 to this, which like by just incrementing 1 to this, we got this, and by multiplying 2 to this, that means multiplying k to this, that is equals to k to this, that is equals to 2, we get this value 8. So, so this is the starting like actual process. But what if you can back propagate something like this in this manner? So it becomes starting from 3 to 2, we have converted into 3, 4, 2, yes, and from this we have converted into 3, 8, yes. So that means only in two operations we can simply perform this. Yes, we are going to get the entire process in just two operations. In this way, if you can simply move forward, that may actually help us. Okay, let us take this example as well as one other example. Let us say I want to convert this 4 into 6 with the help of the value k is equals to 2. Yeah, so let us try to figure out a few cases and let us build some logic for this. Yeah, so this is going to be a, this is going to be, and this is going to be k, a, b as well as k. Yeah, so at what particular point you can perform this operation? Yes, at what particular point? So you're going to say I can simply multiply k to this. Yes, I can simply multiply k to this. So can you just simply multiply k all the time? That means in reverse manner you're going to divide k to this, right? Divide k to a, sorry, k to b. So can you just simply perform this operation any number, like all the time? No, right? You can perform this operation only if b mod k, if that is equals to 0. Yes, if that is equals to 0. Let us take something, some other example. Let us say 4, I want to convert it into 15 with the help of, let us say, 2. So can I just simply perform the same operation, something like I can simply mod by 2, yeah, I'm going to get 7, sorry, I'm going to divide 15 by 2, I'm going to get 7. So that means like it reduces to 4, 7 and 2. Yes, does it actually make sense? Because I have multiple options. I can simply increment and multiply 2 from there and there itself, or else I can simply multiply and add 1 to them then and there itself. So for these operations, as these many number of like two different operations are possible, so we're not going to consider this possible value which is not having like, so which when divided with value k is not going to give is the remainder equals to 0. Yes, so we're going to consider only the case when b mod k, if that is equals to 0, we are going to consider this. Yes, and let us also take one other example. Yes, for this case, what if you can simply multiply, like what if you can simply perform this operation as we discussed earlier? So as we discussed, i want to I want to do something like 6 by 2. So if you want to perform this operation 6 by 2, what actually do we get? Yes, this reduces to 4. 6 by 2, what do we get? Yes, 6 by 2 we get 3 as 2. Yes, so we get 4, 3 and 2. But if you look at this value 3, is this larger or smaller than 4? Obviously this is smaller than 4. So this smaller value is like, if the value is some value is present, we are going to reduce it. But at this particular point this is even smaller than 4. So when this is even smaller than 4, can we just simply consider this many number of operations in which we might have like divided by k? Obviously we should not. Yes, obviously we should not, because I want to convert this a into b. Yes, but I cannot simply subtract a value here to get this value 3. So this is not a valid case. So this is not a valid case. So based on what we can generalize to say this is not a valid case. So if you see here, when we try to multiply, like when we try to apply 6 mod 6 by 2, we are going to get 3, and which is smaller than 4. So when this is smaller than 4, we are not required to perform this operation. So let me also add an extra condition here, saying that if b mod k, if that is equals to 0, as well as b by k, if that is only greater or equals to a, I'm going to consider this. Yes, so what I'm going to consider this, what actually happens to b has reduced to b by k, b equals to b by k. So this is what actually happens. Yeah, and what else if this is not the case, if this is not the case, but this 6 mod 2 is once again equals to 0, we are even supposed to handle this. Yes, how can we handle this? So when we perform 6 mod 2, when we get a value that is smaller than the value a, that means obviously some number of times you're going to add this value to get the value 6. Yes, so how many number of times you're going to add it? You can simply get it something like that is going to be b minus a. Yes, with performing b minus a, you can get the number of operations. You have multiplied 0 number of times, but you have added 1 to 4 2 number of times, with the help of which we have converted 4 into 6. So can we just simply write the condition here saying that if b mod k, like in if we are done with this, in else if we are going to say if b mod k, if that is equals to 0, once again what you're going to do, I'm going to simply increment my answer saying that answer plus, let us say answer where I am here, and if you try to perform this operation once again, I am supposed to increment my answer plus equals to 1, answer plus equals to, what is the answer that I am supposed to increment by? Yes, so answer plus equals to b minus a. So this is the way what that you're going to do. And what else we are left off? What if this is not at all divisible? What if this is not at all divisible? So as we discussed earlier, 4 15 2. So 15 by 2, this is not at all possible to divide. So instead, what if we can simply convert this to something like 4 14 and 2? So this is a possibility, right? If we can simply convert this into 4 14 and 2, maybe there is a possibility that we can move ahead. Yes. So I can simply say in the else, this is going to be else if, and this is going to be if. In the else, what I'm going to do, I'm going to simply perform this operation saying that answer plus equals to, how many times I need to add answer for this? Yes. So if it is this, I'm just incrementing, like I'm just decrementing by 1, and my answer has become, like answer has becomes to 14. That means I have incremented my answer to 1. Yes. Instead of this, what if you can simply take a value, let us say 15, but this value instead of 2, what if you can simply take something like better value, let us take it 17, as well as this is 7. So how many times you are supposed to reduce? I need to reduce it to the nearest multiple, which is for the 7. Yes, so I need to reduce it to the 14. Yes, once again I need to reduce to 14. So if I want to reduce to 14, how much time, like how many number of times I need to perform this operation? Firstly, I need to reduce to 15, sorry 16, then 15 to 14. So 3 number of times. So can I just simply add something like b mod k number of times I am going to add it to my answer, as well as whatever the value of b is going to reduce by b minus equals to b mod k. So this is the way you're going to handle this. Yes, and each and every time when you get a value, you're going to perform the exact same operation. Once again, when you get a value, when you get some a, b, and c, once again these a and b, if they are not equal, you're going to perform the exact same kind of operation. Yes. So as you're performing the exact similar kind of operation, why can't we why can't we once again use recursion here? Okay, let us try to write some code for this as we discussed. Yeah. So let us go to the full screen. Let us try to convert this first operation as minimum number of operations 1, and let us write some logic that we are required for now. Let us say public static int minimum operations. What all things we require? Int a, int b, int a. These all things we are required. Yes. Let us take some helper function. Let us name the helper function as public static int minimum operations optimized, and let us name take the parameters. A is required, int b is required, int k is required, as well as some answer, int answer. Yes. Yeah, here we are going to return minimum operations optimized, call this function with value a, b, k, as well as the value answers to be 0 in the very start. Yeah, as we discussed, what is the first condition that you're going to write? If b mod k, if that is equals to 0, and b by k, if that is greater or equals to a, we are going to call the same function, return minimum operations optimized, and the value of a remains as it is. Whatever the value of b, so b will be, let us go to this once again. Yeah, so a remains as it is, b is reduced to b equals to b mod k, Yes, b has reduced to b, sorry, b by k. Yeah, so b by k, and whatever the value of k, it remains as it is, and answer plus 1. So this is the thing that you're going to do. Let us write else if what about this? What is the second condition? What if b mod k if it is equals to 0? What if b mod k if that is equals to 0? What we're supposed to do? Return, what you're going to return? Answer plus b minus a number of operations which are left over. B minus a. So this is what you're going to return. And finally, what if this is not divisible by k? What if b is not divisible by k? Else, what you're going to return? Return minimum operations optimized. The value a remains as it is. Whatever the value b, b has reduced to b minus b mod a, as well as value a remains as it is. A remains as it is. And how many times you're going to add answer to this? Answer plus b mod k. This is the number of times. So let us go back to it once again. So if b mod k if it is 0 and b by k if it is greater or equal to, I'm going to return minimum operations with reduced value of b by k and answer plus 1. So if b mod k if it is equal to 0, you're going to return answer plus b minus a. This is the number of operations, or else you're going to return minimum of a comma b minus b mod k comma k remains as it is, and answer will be incremented by b mod k. Yes. So we have this. We just called the system.out. It is running. Okay, I expected a semicolon. I just forgot here. So we got output as 322. Let us exit the full screen. Yes, we got output as 322. Let us copy this input. Let us paste it here and once again run. So we got output 322 in the same exact same. Let us submit. So we got correct answer. All the test cases passed. Yeah, all the test cases passed. So let us try to figure out complexity. What is the complexity for this logic that we have reduced, that we have optimized? So let us take an example. Let us say I have the value of A is 1. I have the value of B is, let us say, 64, and let us say the value of A that I want to take, sorry, the value of K that I want to take is 2. Yes. So how to get the 64 from 1? Yes, you're going to multiply 2 to this, you're going to get 2, multiply 2 once again, you're going to get 4. That means 4, 8, 16, 32, 64. So how many number of operations? Yes, 2 power 32, sorry, 2 power 5 is 32 and 2 power 6 is 64. That means 6 number of operations. Yes, 6 number of operations. I need to somehow get 6 number of operations. Okay, if I can simply assume this as number of operations that we're going to perform here is going to be log b base k. So if I can simply assume the overall complexity is log b base k, let us try to figure out how this complexity is log b base k. Yes. So what is b here? So it is going to be 64 base with 2. Yes. And instead of 64, what if I can simply write 2 power 6 base with 2, and this is going to be 6 log 2 base 2, and number of operations are going to be 6. So here itself we got 6 number of operations. In the same manner, we are going to get the number of operations that we are required to convert 1 to 64 is going to be 6. And let us take one other example. Let us say it is 1. Let us say 81. My value of k is going to be 3. So for this, what do you think the minimum number of operations? So if I try to multiply 3 to 1, it becomes 3. And once again multiply 3, it becomes 9. Once again multiply 3, it becomes 27. And once again multiply 3, it becomes 81. So minimum number of operations is going to be 6 operations. Sorry, 4 operations, right? It is going to take 4 operations. 4 operations. If you can simply put in the same logic log b base k, so we're going to get log 81 with base 3. This log 81 can be expressed as log 3 power 4 base 3. Yes, so 3 square that is going to be 9, 3 power 3 cube that is going to be 27, 3 power 4 that is going to be 81. So it is going to be 4 times of log 3 base 3, that is going to be 4. So total number of operations that we found here are going to be 4, as well as this is going to be 4. So if I can somehow reduce the nearest multiple, I'm going to get these kind of operations. So obviously this is not this number of operations. Some k number of operations are also left over. So like not k, some m number of operations, some constant number of operations are also left over. So we can simply assume, in general, we can simply assume the complexity of this logic is going to be big O of log b base k in terms of inputs. Yes, I hope this logic is clear. And also we can write instead of this recursive way, like instead of this recursion, we can also write in different manner. Let us also see about this. So minimum number of operations. Yeah. So let us just simply write here itself. So we have A, B as well as K. So as we have expressed in terms of conditions, we can simply say if, let us take these conditions. Let us take these conditions. As we require something like answer, we just initialize to 0 in the very start. So instead of returning this, what actually happens to A? What actually happens to B? Yes. So if B mod K, if it is equals to 0, control yeah. If you see this expression, what actually happens to B? What actually happens to B? B has reduced to B by K. So can I just simply perform this saying that B equals to B by K? Yes. K. And what about the value of answer? Answer has incremented by 1. K. And in the next step, answer plus equal to 1. Yes, we are done with this. So can we just simply comment this? Yes. And what if this is a situation? What if this is a situation? Can I just simply return, instead of returning, can I just simply say answer plus equals to b minus a? This is one way of doing. Yes. And what about the third one? So if this is not possibility, I'm going to say answer plus equals to, what we're going to add to here is b mod k, right? Let's copy and paste it here. B mod k. Let us put semicolons for this. Yes. Answer plus equals to b mod k. And what about the value of b? B has reduced to b equals to b minus b mod k. So b has reduced something of this form. And finally, what you're going to do? So this is for this if, this is for else. Finally, what you're going to do? You're going to return answer. Yes, you're going to finally return answer. But until what point you're going to perform this operation? Yes, until at some particular point, until the value you're going to add b minus a to this. So let us simply take all this and put it into this and write a condition above this. While true, I'm going to perform all these operation. While if it is true, I'm going to perform all these operation. Yes. And finally I'm going to return this. But when I'm going to stop this, when I'm going to stop it, so at some particular point when b mod k, if it is equal to 0, I'm going to add b minus a to this, and you can simply stop here saying that break at this point. Let us try to format this code. Yeah, so let us try to run this. Okay, I just missed a semicolon and break. Add the semicolon, run once again. Answer semicolon, let us check it now itself. B mod k, yes, yes, yes. It should be executed. So cannot find symbol answer. 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 I just mentioned answer. Sorry, I haven't declared this saying that int answer. Any other declarations? Yeah, we got an answer. Let us first verify this with the input and output. Yes, 3 to this is the value same. Let us write it out. Yeah, finally we got all the test cases passed. So we discussed two ways of doing this. So one is by using recursion and other by using just normal iterative method. And first thing, that is very general step, yes, that is using recursion. And we have reduced this to a recursive code, that is to the log complexity of log b base k. Yeah, I hope that is clear for everyone. Yeah, moving back to another problem, graph cost. You're given an array of size n and a complete weighted graph with n nodes. And if there are n nodes, it will also mention like there are n into n minus 1 edges which are possible, which are undirected as well as weighted edges connected to each and every pair of each and every nodes. Yes. The weight of the edge between I and j, node I and j, is something like apply mod, that is absolute value of j minus I times of maximum of a of I comma a of j. So this is the edge weight. This is the edge weight. The distance between two nodes is defined as minimum sum of weight on a path connecting two nodes. Obviously, the distance is going to be the minimum sum that is connecting these two nodes. Yes. Find the distance between 1 and n. Okay. You're given n nodes in line starting from 1. You're supposed to find the distance, minimum distance from first node to nth node. Yes. Okay. Let us go to the examples. Let us go to the first example. There are four nodes. Four nodes. So there are four nodes. Let us take this 2 1 1 1, right? Yeah, so it is 2 triple 1 4 nodes. Let us move this. Yeah, so 4 nodes, as said, 4 nodes, 2 triple 1. So let us take 4 nodes, first node, second, third, as well as fourth. It was also mentioned the weight of each and every edge is going to be j minus I, absolute value of j minus I times of maximum of a of I comma a of j. Yes, so let us go to that. So as expressed, so the weight of this particular edge is going to be, as this is not directed, let us remove this. Yeah, so the weight of each and every edge, weight of this edge, this particular edge is going to be maximum of this comma this multiply with the distance between this. That means j minus, that is this is 0 1 2 3. So 1 minus 0, that is 1, 1 into 2, that is going to be 2 here. So 2 minus 1, that is going to be 1 1, and the maximum is going to be, so out of these you're going to get 2 here, out of these you're going to get 1, out of this you're going to get 1. So 1 1. So this is how you're going to construct a graph. And obviously if you want to have a node from this to this, sorry, this is already been taken, right? Yeah, so if you want to have a node from this to this, so weight is going to be, weight of this particular edge is going to be the distance between these. That means at the index distance is going to be 2 minus 0, that is going to be 2 times of 2 times of, so 2 and 1. What is maximum of 2 and 1? That is going to be 2. So distance is, the edge weight is going to be 4 for this. So this is the way each and every edge is being mentioned in such a way that there are n into n minus 1 by 2 edges which are possible. So if I can simply assume there are four nodes, how many edges which are possible? Yes, so 4 into 3 by 2, so that is going to be 6 edges at max. So if I can simply name it, start naming it, so this is first, second, third, fourth. I can also have an edge from here to here, which is going to be fifth. Yes, so first, second, third, fourth, this is already taken. I can also have one other edge from 2 to 4, this is going to be sixth. 3 to 4, there is only one which is possible, which is already taken. This is not directed. Let's remove this. Sorry. As well as for this. Yeah. So these many number of edges which are actually possible. So out of all these edges, you are supposed to find the minimum cost to go from first node to nth node. Yes, this is actually given problem statement. Okay, so let us take an example. Let us take a better example in the sense, like, let us take this example as given. This is the last example, I guess. 24523. Yes, so this is the last example, 24523. I have also taken one other example. Let us also discuss on that. Yeah, so firstly, moving back to this 24523. So that means there are 5 nodes in total. 5 nodes. Let us first take this is first node, second node, 3, 4, and 5. So 5 nodes are possible, and the edge weight is going to be maximum of these two, that is going to be 4, maximum of these two, that is going to be 5, 5, and 3. So edge weight are going to be 4, 5, 5, and 3 respectively. Yeah, and you're supposed to find the maximum cost that it actually takes to reach the nth node from first node, and cost of going from one node is going to be the weight of the particular edge. Yes. So in what all ways I can reach this particular node 5? Yes, I can simply reach this node 5 in all the ways which are possible. Yes, I can move from 1 to 2, and then from 2 I can simply use this particular process. Yes, that means this is the entire process in which I am following. Or else I can simply do like 1 to 3, and then from 3 to this. Or else I can simply move from 1 to 4 and 4 to 5, something of this kind. Yes, and directly I can simply move from 1 to 5. So these are all P's which are possible. Yes, making sense, right? These are all P's which are possible. And if you see here, if I want to move from 1 to 3, 1 to 3, is this only one possibility? Like I can move from 3 to 5 directly? Is this only one possibility? No, this is not only one possibility, because from 3 I can once again go back to 4, and from 4 I can once again go back to 5. Yes. Or else, let us assume even there is one other node, let us say sixth node. If I want to reach to this particular node, I can simply go to 5. I can simply go to 5 and then move to 6, or else I can simply move to 4 and then directly from 4 to 6, or else from 4 to 6, like the 4 to 5 and 5 to 6. So these are my number of ways which are possible. So for this, let us try to figure out a way in which we are going to get the minimum cost to get, like minimum cost to reach nth node. Okay, yeah, so let us take this 2 4 5 2. This node is not the right 3. Yeah, 2 4 5 2 3. So out of this, so if you're starting from the first node, it was also mentioned that cost of each and every edge is going to be, yes, absolute value of j minus a into maximum of a of I comma a of g. Let us write it here. Absolute value of j minus I times of max of ai ag. Yeah, so this is the way you're going to calculate weight of a particular edge. So in the similar manner, if I want to get like this value to be minimum, so if I can simply get this value, if this is a minimum, because I'm going to multiply some value to this, yes, some value. Obviously we cannot reduce this, because for each and every index we are going to j minus a j minus b. This is the operation that you're going to perform. If I can somehow reduce this value, that means maximum of a of I comma a of j, obviously this entire value will be reduced. Yes, so how can I reduce this value? Obviously the first value will be obviously the same, because I'm going to start from 2. Yes, I'm going to start from the first one, that is value 2. Yes, so that means if I can somehow figure out the second value that is nearest to the value of 2, or else smaller than 2, that will be fine, right? Yes, so we went with the logic saying that a of j should be smaller or nearest larger to a of I. Yes, making sense, right? A of j should be smaller. A of j should be smaller, or else it may be equal, or else nearest larger, the largest value which is very nearest to a of I. Yes. So with this we can simply get a value that is nearest to a of I. Yes. So let us try to find out what is the value which is nearest to this, or else smallest to 2. Yes, we only have one value which is nearest to this and as well as smaller, that is 2. So I'm just directly jumping from the node 1 to node 4. Yes, node 1 to node 4. And what is actually the cost of jumping from node 1 to node 4? Yes, if you go with this process, what is actually cost of jumping from node 1 to node 4? Yeah, so cost is going to be the index difference, that is going to be 0, 1, 2, 3, 4. So that is going to be 3 times of 3 minus 0, that is 3 times of the maximum of this and this. What is maximum of a of I and a of j? That is going to be 2. So that is going to be 6 is the weight of this particular edge from 1 to 4. Yes. So after reaching fourth node, what is the other possibility that I can reach the destination? Yes, there is only one possibility I can reach the destination by using this particular path, and that is going to be the 3. Yes. So I can simply move from this to this with the help of this particular node, and this will be equals to 3 in weight. So overall cost of reaching the destination from source is going to be 9, and which is the minimum. If you try to verify the maximum value, which like the minimum value which is possible, which is going to be 9, and no other value is going to be smaller than 9. Yes, let us also take one other example as discussed. 4 4 4 4 4 5. So 3 3 7 7 nodes are there. Let us take nodes: first, second, third, fourth, fifth. These nodes can be in any of the direction, like something like any diagram, like different structure, but as for the simplicity, I'm just taking in a linear fashion. 6 as well as 7. Yes. Yeah, so here it is going to be 4, it is going to be 5 5 4 4 and 6. So let us take these differences. So edges weight: 4 5 5 4 4 as well as 6. So these are going to be edges weight. Yes. So as we assume, as we got to know, this is 0. Yeah. So let us take this array of values below to this particular graph: 4 4 5 3 4 1 6. Let us take this indices: 0 1 2 3 4 5 6. Yes. And let us start now. Yeah. Now what else can we do? We are starting with this first node, that is with the weight of 4. Yes, with the value of a of 1 is going to be 4. So I need to figure out some value which is smaller or equals to 4. Yes, smaller or equals to 4. What all possibilities I can reach? Yes, you may be thinking like I can move from 4 to 2, and then from 4 I can move to once again this 4, and from here I can go to 1, and from this I can reach this destination. Yes, so this is one way of doing. So this is one way. And if you try to see, are there any other possibilities? Let us move this. Yeah, let it be there. Let it be there. Yeah. Or else from 4, instead of going to this particular 4, what if I can simply directly go to this particular 3? Yes, and from this 3 I can simply go to this 1, and then from this 1 I can simply go to this 6. So this is one way. And is there any other way which is possible? Yes, what if I can simply go from this particular 4 to a value that is, let me write it to the below itself because this becomes clumsy. Yeah, so I'm just simply going from 1 to 6, because if you see here, value of 6 at this particular point is 1, but here the value is 4. So I have chosen the first, that is smaller, and then from there I'm just going to choose to 6. These are all the different paths which are possible. So if I want to choose the first path, that is with the green, so what is the weight? What is the weight of each and every edge of this particular graph with green edges? Yes. So firstly, it is going to be of weight 4, because it is going to be of weight 4 after this. So there is a distance of 2 in between, and this is 4, and as well as this is 3. So if this is 4 and this is 3, you're going to take the maximum of this, and the distance is going to be 2 times of 4, that is going to be 8 here. And if you see here 4 and 6, once again the distance is 2. 2 times of the maximum is going to be 3. So 2 times of 3 is going to be 6, as well as here the distance is 1 and the maximum is going to be 6. So if you see here with the green, we got the distance, total distance from reaching destination from source is going to be 4 plus 6, that is 10, 10 plus 8, 8, 10 plus 8, 18, 18 plus 6, that is 24. So we got a value that is 24. Let us also verify with some other values and see, like, are we getting some value which is smaller or not. Yeah, so let us go with the one that is marked with red, the graph with red edges. Yes, so if you see here 3 minus 0, that is 3. 3 times of maximum of 3 comma 4, that is going to be 12. So we're going to take 12 here, and once again here the distance is going to be 2. 2 times of maximum of 3 and 1, that is going to be 3, and once again it is going to be 6, and here it is going to be 6 anyhow. So overall for this red with red edges is going to be, so 12 plus 6, that is going to be 18. 18 plus 6, that is once again going to be 24. So we got two values that is equal to 24. Let us also go with the one that is marked with purple. Okay, for this the distance of indices is going to be 5 minus 0, that is going to be 5. 5 times of, let me take purple here, so 5 times of, and what is the maximum of a of 1 and a of 6? It is going to be 4 and 1. So you're going to multiply 4 to this, you're going to get 20 here, and this is going to be 6 obviously. So overall it is going to be 26. And out of these, what you're going to return, the minimum distance, minimum cost to reach from source to destination, and which is going to be 24, any of these. That means you can either follow the path that is in green color or else the path that is in red color. So any of this will be a valid. Yes. So what is logic? What is the logic that I need to get? So instead of choosing the one that is having minimum in the very start, like very smallest, what if we want to choose the first smallest, or else the first one which is nearest as well as smallest to the value a of I? So that will be our logic. If you can somehow figure out this value, which actually helps us to get this. Yes. Yeah. So let us try to just directly go for code for this particular problem. Exit the full screen, enter full screen for this code. Yeah. So let us say this is the entire input logic. For each and every test case, you're going to read array as well as the value n. For each and every array, like, you're going to read the array values, and you're going to say cost is going to be calculate cost. Let us say there is a function calculate cost with n lst, and you're going to return this cost. Let us try to implement this calculate cost, and this calculate cost is an integer function, and which is going to take a parameter n. This is the size of this particular array as well as the list. Yes. So what is the first step that we are going to do? I need the minimum, the least nearest possible value which I need to take. Yes. So let us start something like this. While, let us say, some value int I equals to 0, because I'm going to start from I, that is going to be 0. So if I'm starting from I need to get a value that is minimum from first index to nth index. Making sense, right? First index to nth index. So for this I'm just taking I. So I is less than n. While I is less than n, I'm going to start iterating from I plus 1 to n. So let us say for int j equals to I plus 1, j less than n, j plus plus. What I'm supposed to do, I need to check whether this lst of j, if this is less than or equals to lst of I. Yes, if lst of j, if it is less than or equals to lst of I, what I'm supposed to do? Yes, I got a value from which from the source I need to move to this particular value. So if I want to move to this particular value, it costs me some value. Let us take a variable that actually costs us. Int cst actually indicates cost. Yes. So what is the cost that it actually takes to move to this particular lst of j? Yes, let us say simply cost plus equals to, what is the cost that is actually going to take for this? So actually it was mentioned something like j minus I. Obviously this value of j is larger than I, so for this reason I'm just directly taking j minus I, multiply with, and what is this? Multiply with maximum math dot maximum of lst of I comma lst of J. So it was just mentioned something like graph problem, but actually this is not a graph problem. This is just a simple problem, but to make it the to make the problems look like some kind of graph problem, he had mentioned saying that this is a graph problem. Yes, yeah. So we are not at all required to apply something like BFS or something else. Not at all required to construct the graph. We are just going to use a simple, very basic logic. So cos plus equals to j minus I multiply with math dot max of LST of I comma LST of j. So what is the other thing that after doing this? So after getting the cost, so that means we are done with this particular. That means my starting value of I is at 0. Yes, I got some value j which is somewhere else present here, and I have calculated the distance cost of moving from I to j. So this is done. Now I need to move my I to this particular value j. So that means, can I just simply assign the value I is going to be j here? Yes, I is going to be j. After this, do I need to even go further? Yes, can I just simply break here saying that we are done moving here, and I'm going to break this entire for loop. So after breaking this, my value of I is going to be modified to j, and my j value is going to start from I plus 1 with the very start once again. Yes, and this is the condition that we have wrote. But what if this is LST of I? If it is not equal to LST of j, if you are iterating the entire array, but we do not find any value which is less than or equals to LST of I, what if this is the condition? We are supposed to find the nearest value. Yes, we are supposed to find the nearest value. So for this nearest value, can I just simply go into the else, saying that else we did not find any value which is smaller or equals to this. So we are supposed to find the nearest value. So if I want to find the nearest value, let us say mi is going to be math dot min. I need to find the minimum value mi comma lst of j. So obviously I need to first initialize this mi. So how can I initialize this mi? So inside this while loop, I'm going to say int mi is going to be integer dot. Firstly, if it is a maximum value, at each and every point, if I get a value that is smaller than this, I can simply include integer dot max. So integer dot max value. So I'm going to take mi is going to be integer dot max value. I'm just simply iterating. If I did not get any value which is smaller or equal, I'm going to enter into this else. In this else, mi is going to be math dot minimum of mi comma lst of I. Along with, I also need to store the index. Making sense, right? I also need to store the index of that particular lst of I. So let me also take something like int idx equals to I in the very start. As I already have I, I'm just taking I semicolon here. Yes. So instead of saying that mi equals to math dot min or something of this kind, if it is less than, I'm supposed to take yes. If lst of I, sorry, lst of j, if it is less than mi, what I'm supposed to do? I'm supposed to make mi equals to lst of j. Yes, as well as my index, I need to update my index. idx is going to be j. Yes, so we are done with this. So that means we are starting with I plus 1, I less than j plus, like j is going to be I plus 1, j less than n, j plus plus. If lst of j, if it is less than or equal to this, I'm going to calculate c count, cost is going to be this. I'm going to break it there, and I'm going to start from the next iteration moving my value of I. Yes, at some particular point, if this doesn't exist, I'm going to enter into this else. I'm going to find the nearest possible smaller value which is larger than lst of I. So LST of I, if it is less than mi, I'm going to make mi equals to LST of j, as well as LST of like idx equals is going to be j. But when I am supposed to perform this operation, if I have done with this, do I need to perform this operation? No, right? Only after, like, after completion of this entire for loop, completion of this entire for loop, I'm going to get, like, I'm supposed to add into this, right? Yes, I'm supposed to add into this. So that means this is for this, this is for this. Let us remove these two lines. Yeah, so I also need to maintain an extra flag variable, so that if I have encountered a minimum value, I'm going to break it there. After breaking there, after completion of this entire for loop, I'm not going to encounter some particular line of code that I'm going to write it here. So for this, let us take a flag variable. boolean flag equals to false in the very start. So I'm going to take a boolean flag is equals to false. So when I just got this value, I'm just making my flag equals to true. So I have made my flag to true. After my flag, at this particular point, when I encounter this entire for loop, when I'm done with this entire for loop, so as I'm done with this entire for loop, what I'm supposed to do? I'm supposed to check whether my flag is once again still false. If it is false, I'm supposed to add my answer. Yes, I'm going to say if flag, if that is equals to false, what I'm supposed to do? I'm maybe moving to the next particular value. Yes, how can I move to this? Can I just simply say count plus equals to what is the value? From I have moved to idx. So idx minus I multiply with what is the value that you're going to multiply with this? It is going to be math dot max of lst of I comma lst of idx. So this is the value that you're going to multiply for this. Yes, so after multiplying this value, what is the next step after multiplying this value? So that means if you see here, if this is present, you're going to make your I equals to j in the next step. If this is not present, you're going to mark idx, which is going to the minimum of all this. So you got some idx in your I is present somewhere else here. When you're done with this entire for loop, you're going to end like exit the for loop. After this for loop, once again your flag is false, you're going to make count equals to idx minus I. This is idx and this is I. Idx minus I multiply with math dot max of lst of I comma lst of idx. Yes, we are done with this. And what is the next step? I need to move my I to my idx. Yes, I need to move my I to my idx. So can I just simply write here idx equals to I? But if I can simply write idx equals to I, at some particular point this it trades internally and moves in an infinite loop. So instead of this, what if I can simply say instead of idx, I need to make I equals to idx. Yes, instead of this, what if I can simply say if idx, if that is not equals to I, what I'm going to do? I is going to be idx. Yes, else I'm going to say I is going to be idx plus 1. I'm going to start from the next number. So finally we are going to get answer that is not count, that is CST I guess. Yes, CST. This is CST, and finally we're supposed to return this cost. Yeah, so this is the entire logic. Once again, if you go to this, so I just took I equals to 0, cost equals to, let us initialize to 0 first. Yeah, so while I is less than n, you're going to take an idx that is equals to I. You're going to take a minimum value that is maximum value. It is going to be capital B. Yes, you're going to take a flag that is equals to false. You're going to start iterate from I plus 1 till n. If lst of j, if that is less than or equals to lst of I, you're going to make count cost plus equals to j minus a times of mat dot max of lst of I comma lst of j, and you're going to make your I point to j at this particular point. And done with this, you're going to mark flag as 2. That means we have encountered a value. You're going to move to the next iteration. In the next iteration, if you do not find anything value, something of this kind, you encounter in this for loop. So when you encounter this for loop, yeah, so when you encounter this for loop at this particular point, if lst of I, if it is less than or equals to in this else, if lst of I, if it is less than mi, you're going to get a value which is minimum. Yes, which is going to be minimum. So after minimum, you're going to update answer something like cost plus equals to I minus, sorry, idx minus I, because idx is pointing here and I is pointing here, minus I my times of math dot max of lst of I in times of lst of idx. If idx, if it is not equal to, I am going to make I equals to idx, or else I equals to idx plus 1. Finally, I'm going to return this cost. Hope I have called this. Yes, let us try to run this once. So I got an error. Okay, I missed semicolons at few points. So when I just click break, I missed a semicolon here. When I just made I equals to I plus 1, once again this particular point. Yeah, symbol says variable lat, so it is not lat, it is lst. Okay, we got time limit exceed. Let us try to figure it out. So so that means this I value is not being updated. So if idx, if it is not equals, I'm going to update I equals to idx. If flag is false, I'm supposed to do this. I'm just making my idx equals to j. When I'm done with this entire for loop, I will be done with this. I'll be moving to this. If flag is false, I'm going to make this. Okay, what if I can simply remove this and place it in this itself, format it, run it. So we got values as 24, 5 and 9. Yes, this value which I actually took as an example, hope you remember this. So 24, yeah, 4453416. So 4453416. So this is the value which we took. Let us try to verify with this input. Yeah, so 5 and 9 we got for the second and third test case, we got 5 and 9. Let us just simply take this test case, control V and run it. So we got 4, 5 and 9. Let us try to submit this. So we got time limit exit. If you see here, all the test cases passed, but the last test case got a time limit with a time of 1.99 seconds. Okay, so let us see the code once again. So this is the entire logic which we have already wrote. Calculate cost if I equals 0. This is the thing, and the just thing that we have modified here is something like earlier this was outside the if condition, but I just moved into this if condition, saying that I need to execute this only if my flag is false, because at this particular point obviously I'm going to break and make my I equals to j, because for this reason I'm not all required to execute this outside this, I just moved it inside. So with this I got TLD. So let us try to figure out some other solution for this instead of this. So moving back to this particular problem, let us take this example. Yeah, so let us take this example 4 1. Yeah, so let us take the example 4 1 5 3 4 1 1 and 6. Yes, so for this example what I'm supposed to do, I need to firstly somehow figure out the first smallest. Yes, first smallest. How can I figure out the first smallest? I need to firstly figure out this first smallest. So obviously I'm going to do this point. So if you see here, if any of this for any of these particular cases, so we got two outputs which are possible, which are actually possible. And if you see here, we are starting from 1. Obviously we are moving to the second index. Yes, second index, because we got a value which is near to the particular value, and obviously we are moving to this particular last n-1 index. That means it is making sense that we are moving to a value which is just smaller compared to the last destination value, as well as we're also definitely moving to a value which is just smaller or equal to the value which is nearest to the starting point, that is the source. Yes, so obviously we are going to move to this particular point, this as well as this. Yeah, so with this particular point let us move further. So if you see here, also for this particular example, so I want a smaller value from this until this entire process. So what is the smaller value from this first source node? So this is the smaller value, right? This is going to the smaller value. And in the same manner, what is the smaller value from this destination source? This is the smaller value. If I can somehow figure out a smaller value from this and smaller value from this, that means obviously if I want to reach destination, I need to somehow move to the smaller value from the source and once again from the smaller value to the destination. So the path may be something like this: smaller value from source, smaller value from destination. Let us assume this as destination and this as source. So obviously you're going to choose a path something like from this to smaller value of source, and from this you're going to move to the smaller value of destination, and from this you're going to move to the destination. So maybe this is one kind of logic in which you can perform this entire operation in simple number of iterations. Yes, and what if this smaller value of source and smaller value of destination, both of these are equal? You're going to consider this as a single term. So let us discuss this. This is smallest from source as well as this is smallest from destination. That means smallest on this particular side as well as smallest on this particular side. And when you get the smallest, so you're going to definitely move into this particular, and you're going to assume now this as source. So when this is source, you're going to get once again smallest source here, and once again if you assume this as destination, you're going to once again get smallest destination here. So in this particular pattern you're going to expand, like converge from both the sides. If you can converge from the both the sides, we may get a value. That means maybe these two values may get converged, or else if they do not converge, we are going to get even this difference. That is going to be once again one more way of moving in this way. These smallest source from these to destination, smallest destination, and these to this, and these to last destination. So this is the way we are going to follow. Okay, so as I said, so firstly if we go to the previous example, firstly, so if we want the smallest value that is nearest to 1, so firstly for this you're going to start from the first node and you will be reaching the second node. So this is the first part that you're going to follow. After this what is the next step? So you're going to search for the smallest one, and that is 3. You're going to reach this, and you're going to once again search for the smallest one, that is this 6, and you're done with this because we do not have anything that is even smaller than this. Yes, so we do not have anything. We can simply also perform the similar kind of operation. We can assume this as destination, and we need the smallest one towards its left. So we found that this is the smallest one, so that means we have moved in this manner until this part, and we are moving in this manner to this part. Yes, and we have reached this particular point. If we can somehow know the minimum cost of this as well as the minimum cost of this entire process, we can simply get the minimum cost of this entire process. Yes, so this is the entire logic. So let us try to implement this kind of logic. Yeah, this is the code that we have wrote before. Let us try to take this. Let us modify it as 1. Yeah, so as we discussed, what is the first step that I'm supposed to do? I'm going to take start iterating from 1 for, let us say, int I equals to 0, I less than n, I plus plus. As I said, I need to start iterating from 1, so this is going to be 1. I need to compare with the previous. Let us first take int previous, or else int source is going to be 0. As also we also require something like cost to be 0. Yes, in this what we're supposed to do, if lst of I, if it is less than or equals to lst of src, what we're supposed to do, if this is the condition, if lst of I, if it is less than or equals to lst of source, then cst cost plus equals to math dot max of lst of I. One parameter is going to be lst of I, other parameter is going to be lst of src source, multiply with the index difference, that is I minus src, because obviously this I value is larger than src. And what about source? You're going to make your source move to the next one. src is going to be I now. And as we discussed, if this is the given condition at some particular point, what if your source reaches the destination? So that means that its destination is going to be n minus 1, n minus 1 index. So if your source reaches the destination, what you're going to do, you're going to return the count, that the cost that you have that occurred for you. Yes. Finally, if this is not equals to destination, how you're going to check whether this is equal to destination or not? You're going to say if src, if that is not equals to n minus 1, that means we haven't reached the destination. Yes, if we haven't reached the destination, what we are supposed to do, even we are supposed to start iterating from the backward side. Yes, so we are supposed to start iterating from the back end, so back side. So if you want to start, you're going to say let us say destination is going to be n minus 1. Yes, you're going to start for, let us say, int I equals to n minus 1, starting from n minus 1, until what value you are supposed to iterate, until it is greater or equals to source, until I greater or equals to src I minus minus. Here what we are supposed to do, if this lst of I, if lst of I, if it is less than or equals to lst of destination, maybe this is a chance possible, right? If lst of I, if it is less than or equals to destination, we are supposed to perform this operation. If lst of I, if it is less than or equals to destination, we are supposed to increase our cost. cst plus equals to math dot max of lst of I comma lst of destination and the index difference multiply with I. So I is present here and destination is present here. Destination minus I. And what about the destination? Destination is going to be I for the next time, because this is destination, this is I. You're supposed to move your destination to I so that I can simplify next I. Destination is going to be I. Yes. So with this, we are done with this. But at some particular point, what if this source and destination are not equal? So if this is the source and this is the destination, there is even some gap, even we are supposed to traverse. So if source, if that is not equals to destination, what we're supposed to do, simply increment my cost plus equals to math dot max of lst of a source lst of destination multiply with, so this is destination and this source, destination minus source. This is the thing that you're going to do, and finally you're going to return this cost. So for better sake, let us take this as long, and this function is going to return this cost, and finally this cost is going to be long. Let us try to run it once. Okay, cannot find the symbol destination as well as the destination. So I haven't declared, saying that int destination. So we get this output. Let us run it. Let us submit it. So we got all the correct answers. So this is the final answer. So that's it for this. I hope that is clear for everyone. So if you want to discuss this once again, so cost, we are going to calculate cost. So this is something like we are going to assume this as source. We are going to get a particular value to which we want to move. Let us take that as I. So from this source, we are going to move this I, and we are going to move this source to this, and this is going to the next I. We're going to move to this source, and finally, at some particular point, your source stops at a particular point. And conversing from the reverse side, you're going to find a particular value I that you're going to move your destination. And so at some particular point, your source and destination are present here, and you're supposed to find the path difference between these, and which you're going to add it at the end. And finally, you're going to get the result as something like this. I hope that is clear for everyone. Thank you.